Okay, we're still going. As in, I'm still recording this today instead of saving this for tomorrow. Let's actually test that out. Not here. Excuse me. Let's test it out. So supposedly the answer is 3. And here I am forgetting to turn off the window capture. But yeah, again, supposedly the answer is 3. I'll explain that once we move to the next one, so I can at least have that screenshotted and work on. Yeah, basically chain rule. I actually don't know the proof to chain rule. Like, I'm also just not doing the proofs because I'm trying to save time. I'm not doing very well at it, but you know. Okay, let me pull up window capture again. Chain rule is just if you have two functions, which in this case you have 3x and you have sine, you have to hold on. Let me collect. I know it's not displaying the window, but I collected 3. Let me just flash it. There, collected 3. We'll see if that's right because you can just hear. But yeah, you have to take the derivative of the outer function with respect to the inner function, which basically just means assume it's sine of x. Hey, I got it right. Okay, let's screenshot this and move out. But yeah, you have to take the derivative of the outer function with respect to the inner function, which basically just means take the derivative of sine of x with respect to x. Which, because of proofs, whatever. But yeah, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Negative sine. And remember that thing, well, if anyone's still watching. If anyone was watching and is still watching, the thing about constants means you can factor out the negative, -1 here, and you then just get negative cosine. And then cosine becomes negative sine, which leads back, because it cancels out when it becomes negative sine. Don't ask about tangent. Tangent is way worse. Let's get rid of this goofy one. Okay, but yeah. So the derivative of sine is cosine, which means you take the derivative of sine of x, but then you place inside, you keep the original inner function, so you keep the 3 of x. And then you multiply that by the derivative of the inner function. So the derivative of 3 of x, as I explained before, would equal 3. So we got 3 cosine 3 of x. Again, I assume, yeah. Because when you evaluate this at 0, hey, it's L'Hopital's rule. It really is L'Hopital's rule, I think. I think that is true. Because that's the method that this is. Where if you're taking... I don't know the exact circumstances that you need for it. Like, if it needs to be going to 0 specifically. But yeah, if you're taking the limit of some quotient, some f of x over g of x, it is supposedly equal to taking the derivative of f of x, dividing that by the derivative of g of x. Which in this case is true because 3. That one I just don't know that well, so I don't know the proof of it either. But yeah, this evaluates because cosine of 0 is 1. So this would be x would become 0, this whole thing becomes 0, cosine of it would become 1, and then, you know, it's just 3 times 1 over 1, which is just 3. And let's get rid of all of that because we're moving on to the next question. It'd be really funny if it turns out I actually am somehow already verified and YouTube would just keep letting me upload, but I'm still limiting myself to 15 minutes. I'll find out eventually if it seems like my luck is going too far. Anyways, let's see this. Okay. This one's actually kind of easy. Okay, that's a little bit meaner. The critical point refers to x value. A critical point refers to x values where when you evaluate them, when you evaluate the derivative at that value, it equals either 0 or undefined, or like does not exist or whatever. Yeah, so the way you find critical points is you just take the derivative, which again x squared because of power rule, and n times x to the power of n minus 1 with n equals 2. This becomes 1, which just becomes x, and this becomes 2, which means the derivative of x squared is 2x. And again, sum is also a difference rule, sum rule and difference rule. So we can also separate the minus 12x, which again just becomes minus 12, 2x minus 12, and then to find critical points, you have to find ones where this would not equal a value, which because there's no like quotient, or there's no like natural logarithm or like logarithms where if you try taking the logarithm of a negative number, it just fails. Because that's not present here, it's as simple as setting it to 0, and then you get 12, you transpose the 12, you add 12 to both sides. 12 is 2x, and then x is 6. Which means if you take the derivative of this, or if you look at the graph of this at x equals 6, it's flat. Like this is x equals 6. It's exactly flat. So we already have n is 6. And let's take the derivative of this. The derivative, because this is just the sum of x coordinates of all of the critical points, which just means we have to find all of the critical points again. Derivative of, again, we can separate the 1/3. Derivative of x cubed becomes 3 times x to the power of 3 minus 1, 2. 3x squared, we can put the 1/3 back in, which cancels with this. So we have x squared minus 4x, and then that just becomes minus 4. This is a difference of squares, which, as I explained with the first question like 2 or 3 videos ago, oh my god, dude. But yeah, as I explained, can be factored as x minus y, x plus y. And y in this case is 2x, is still just the same. So x minus 2, x plus 2. Which actually makes this hard because, yeah, sum of all of the x coordinates, we have to set this equal to 0, which, because of the factoring we did, means we just have to set one of these equal to 0. Which means this x value to set this to 0 is just positive 2, this is negative 2, to set this one to 0. And their sum is, hey, that's 0, which means we gotta avoid the stars and get 6. We gotta get all 6 coins and avoid the stars. Oh my god, the game is actually a game. We're not just doing math, we're actually... We're not just doing math. I actually have to dodge some stuff. I really like doing this. It's a shame no one's gonna see my fucking math passion or whatever videos. Oops! Okay, I accidentally collected the wrong one. Hey, can I please just start on... But yeah, it's a shame no one's gonna see these, because it's like... When I was in a lot worse of a mood because I was sick and also, like, getting a bit worried about other external factors and stuff, I really got into it. But yeah, I can't blame people for not being interested in this, obviously. I can't blame people for not being interested. Like, people will watch what they want to watch for content, obviously. Though, then again, with the way trends are these days, you know, less and less people are, like, supposedly anyways, and this is mainly from the US, from what I've heard, is that supposedly less and less people are actually, you know, like, doing well in math. And like, a thing that reaches... It's a thing that reaches through, like, literally up to college, apparently. Supposedly. Holy, lock in. Okay, there we go. Yeah, let's go. Dear God. I don't think I'm gonna be able to answer this one. I don't think I'm gonna be able to answer these next ones. That's a worrying interlude. I was trying to look at OBS. Complex analysis. Well, I'm screwed. $300 beats remaining. The value of x. 2i. Right? 2i. Dude. 1 plus... What? What? Dude, this is crazy. That's crazy. Okay, that would equal over 2... That would equal over 2 to the power of an insane amount. But 1 plus I would also become... 1 plus I would also become 1 plus... 1 plus I squared would become 1 plus 2i minus 1. So... Dude, I don't fucking know. This interlude is crazy. Dog, I'm not gonna be able to do this. Actually, okay, let me think a bit more. Because I just realized I am stupid. Okay, so squaring, yeah, if you square it and then have it be squared and then to the power of 37, which does basically the same thing. Yeah, you realize from the square, 1 plus 2i, 1 plus 2i minus 1, so that becomes 2i over 2, which becomes I to the power of 37, which means it's I. It's actually just I. Okay. The real... I don't remember the eigenvalue. Dog, I don't remember. Dog. Six plus I. Dog, what is this? Well, I don't remember the eigenvalue. I'm fucked. Okay, hold on. Oh, well, time for the video then. Bye.